Now you may say, well, big deal, a little bit of kinetic energy, it's more like 1.3 joules. Who cares about 1.3 joules? Well, it is a real big deal in physics, let me tell you. And I can make you appreciate that it is a real big deal by doing the following. I don't change the masses, but I just am going to change the direction of the impact. Here is M1, and here is M2. The speeds remain the same, V1, and this is V2. No change in the numbers, except that they go now head on. What is the momentum of particle number 1? Well, that is mv. 1 times 5 is plus 5. Remember, this is the increasing direction of x. So the momentum is plus 5. What is the other one? That is 2 times 3, that is 6. Backwards. This is minus 6. So what is the total? The total momentum, if I give it the magnitude, equals minus 1. The magnitude is 1, of course, and the momentum, if I leave this off, we would call that minus 1, because it's a one-dimensional problem. The momentum before is in this direction, it's minus 1. So what now is V prime? They stick together. Here they are. And afterwards, I'm not even sure whether they go this way or this way. Yes, I am sure, because the momentum is in this direction. So I predict that V1 prime will be in this direction. And so this now equals M1 plus M2 times the new V1 prime. Well, M1 plus M2 is 1 plus 2 is 3 kilograms. And so you see that V1 prime equals minus 1/3 meters per second. So the whole system now goes off with 1/3 meters per second in this direction. The kinetic energy before has not changed. It was 21.5 joules, right? That is independent of how I collide them with each other. What now is the kinetic energy afterwards? This is a great tragedy, because now you get 1/2 the sum of the masses, which is 3, times this small number squared. Goes with V squared, right? And now there is only 0.17 joules left. Almost all kinetic energy has been destroyed. So what you see here in front of your eyes, that kinetic energy can be destroyed, but momentum cannot be destroyed in the absence of external forces. Kinetic energy and momentum is a totally different thing. The momentum of the individual particles did change, but the net momentum did not change, but the kinetic energy was destroyed. I can destroy the kinetic energy completely if I want that. I can arrange a collision so that all kinetic energy has been removed. Suppose this particle has a mass 5 and the velocity is 1. This is my shorthand notation. And this particle has a mass 1, but it has a velocity 5. The momentum of this system is 0. Plus 5 in this direction, it is 5 in this direction. But you bet your life there is kinetic energy. After the collision, they hit each other. We agreed that they would stick. There was glue on it. Momentum afterwards must therefore still be 0. Internal forces don't matter, no matter what happens. Kinetic energy is 0. So the whole system collides, bing, and afterwards you have here the sum of the total masses, and it just stands still, because I told you that they are going to stick together. I used glue.